Hello everyone. Let's look at today's Leetcode problem 2434. Using a robot to print the lexicographically smallest string. Before starting this problem, let us look at a motivational quote for today. The moment you are about to quit is usually the moment right before the miracle happens. Don't give up. You have been pushing through a problem maybe for weeks, months, and you might feel tired, frustrated, and nothing seems to be going in a positive direction. But you are on the right edge, you are on the edge of giving up. But there might be one small effort which can give you that much required breakthrough to solve the problem that you are looking for. Maybe give it another try, take a small break, come back, give it another attempt. Things might change. So continue your effort no matter how hard the problem is. Stick to your own goals. Let us understand the problem statement. 2434, using a robot to print the lexicographically smallest string. You were given a string S and a robot that currently holds an empty string T. Apply one of the following operations until S and T both are empty. Remove the first character of a string S. Remove the first character of string S and give it to the robot. The robot will append this character to the string T. Remove the last character of string T and give it to the robot. The robot will write this character on the paper. Return the lexicographically smallest string that can be written on the paper. Okay, so maybe it requires us some more understanding. Maybe let us look at an example here. So there is a string S as per the problem statement, and initially there is also a robot which holds an empty string T. So let's say let P denote the return string. So initially P is empty. This is our output string. Initially it's empty, and our input string is this, where uh, we perform first operation three times. So T is equals to ZAA, which means we remove first character of S and give it to the robot. The robot will append to string T. So that's what we see here. In the second operation three times, so the characters in the string T are lexicographically replaced or ordered lexicographically in the output P, and that's the same output that we see here. Okay, so let's also consider this example where, let's say, uh, this is our input string, and perform operation twice P S. Okay, so so we we perform operations two times. So we pick A, B, and A, and we append A and B to the characters B, that is from the last element, and we are doing it. And the initial string S is left with S in the second operation. So we move that to the character temporary string which the robot holds, and this would be C. And finally we perform the second operation, which is emptying the or taking the last character in the T and appending it to the last character in the output string. So this is a lexicographically ordered output, and this is the output that we see here. Okay, so let us also see this example, and let's see what other things we can get to understand here. So BDA, and initially this is the string. We perform operations so that BDA are all populated in this T, which is an empty string initially, and the robot appends each character that we present, and we might want to take the last character from the tree T and put it to the output string P, A D D P. So this is the final output that we are returning here. Okay, so let us look at an approach on how we can solve this problem. So initially let's say we keep track of frequency of characters from input string s. Let's call this step 1, and we move all the characters to stack, and at each step we check if this character is the smallest. In string s. Else we keep adding to the stack. So basically here what we are doing, we are waiting till there is a smallest character and then moving it to the result. So this would ensure lexicographically smallest result. And as per the problem statement, we can perform uh, this operation, this entire set of operation any number of times, where we append append to the stack maybe the t variable that the robot holds, and the last character of the t that we keep appending, maybe we need to check if it is the smallest one in the input string, and then we move it to the result. So that's the operation that we are doing here. So if we would need to have an understanding of how our code should look like, in step 1 we have a frequency array 0 to 26, and we populate all the values. Let's call this step 1, and in step 2 we start off with the stack, and also uh, keep a track of smallest character. So we go from character to character in the string s, which is our input string, and we push to stack, ch push to stack, character is pushed to stack, and frequency of the particular index is decreased, and we check if the specific character is the smallest. If ch is smallest, then result is added with the character. So yeah, this is the whole operation. Let's uh, go to the Leetcode editor and let's try solving this problem. Yeah. As I said, we are going to create a frequency of 26 characters, and this would be filled with initially with 0, and let's get the character code of the starting character, which is the alphabet A, and from here we ch of s and frequency ch dot character code at 0. Now we initialize the stack, and also so we pop, we append, or we add this, we push this particular character to the stack, and we also decrease it from the frequency this way, and we also would need to know what is the smallest character, and if the current character that we are looking at is the smallest one, then okay. And also let me just keep off. And if we are at the smallest character, then we simply pop the element from the stack and push it to the result array, which would be our final string that we need to return. If stack.length is greater than 0, then we simply push all of the other elements also to the result array, and then we can simply return the result array. Uh, yeah, this should be our output. This should be our solution. Let's see what is happening. Okay, so the solution gets submitted, and the time and space complexity of the solution here is, so we are having to store a length of characters s, so that would be O of n, and you see we are, other than that we do not have any other time, any other thing apart from this specific. Uh, this is a loop, and this is a, here we are just keeping track of all the characters frequency in this uh, array of 26 indexes as alphabets range from A to Z. So this is a constant time complexity, while this has a dependency on the input string length. So time complexity would be O of n, and space complexity would be O of n, because we are having to keep it in a stack with uh, the all of the characters from input string being stored in stack and being pushed and popped. Okay, so if you found this video helpful, please like and subscribe to my channel. Thank you.